Welcome to Lesson 27, Learn C Programming on the Raspberry Pi. Well, the last day we did quite a bit of work on using Unicode characters in C. We ended up building a chessboard display, all in text mode, just by using Unicode characters. So I hope you've had a chance to practice with that. And today I want to move back to using the GPIO pins on the Pi. And just before we get to that, I just want to mention that I have had a chance to upload my lessons, at least the code, to my GitHub account. You can see here, github.com/selmys C on Pi lessons. So if you go to with your browser to C on Pi lessons, you'll see here that I have a folder with all of the lessons, and they contain the code examples I used. So for example, the last lesson we did, lesson 26, you can go and you can see the code here for the chessboard we made. So you can download it and try it out, maybe even hack it a bit, enhance it, make it better. That's up to you. Anyway, it's here for your programming enjoyment. Now today I want to swing back to talking about the GPIO pins and driving some piece of electronics. So I want to start by looking at this 7-segment LED display. So here we have a 7-segment display, and you notice it has, on one side it has 9 pins, pin 1 to pin 9, and the other side pin 10 to pin 18. They don't show pin 1 and 18 here, but anyway. So inside this little chip we have 1, 2, 3, 4, 5, 6, 7, 8 diodes, 8 LEDs, and you can see these are common cathode type, which means all of these pins here are grounded. So 4, 9, 12, and 17, we use that as the ground. And then these pin 2, 3, 5, 7, and so on are for segment A, F, E, and so on. And you look down here, you can see segment A. So segment A, segment B, C, D, E, F, and G is in the middle. And then we have a little dot down here representing, if you look here, DP. This is the decimal point. I'm not going to be using the decimal point today, but we'll just use the 7 segments to make up the digits 0 through 9. Okay, so let me push this aside for a second, and I'll bring up my display here, video camera. And you can see the video. On the video camera I have some items here. I have 2 of these 7-segment displays. I have a 1K resistor, that's 1000 ohms. I have a few little wired connection wires or jumper wires, and I have here a little battery that's 2 1.5 volt cells inside, so a total of 3 volts. Okay. So just to show you how it works is, if you look at the bottom of the thing, you can see all of the pins are there. It even shows you how they're all connected up. There's a little diagram at the bottom. So what I'll do here is just to show you, I'll put this green wire into pin 9, which is ground. I think that's pin 9, and then I'll put the yellow one into pin 2 like that. So I have pin 9 and 2. That's pin 2 and that's pin 9. So if you go here, pin 2 and 9, 2 is connected to segment A. So that's this top segment should light up. So if I just, without using a resistor to limit the current, I'll just plug in the battery here. Plug in the ground first, the negative side, which is the black wire. And then if I just touch this one, you should see the light come on. There it goes. You can see it works. So that segment is coming on. Now if I put a resistor in series with that, then of course it wouldn't come out as bright as this is. Okay, so it's probably a better idea to put a resistor in with that. Okay, so let me move this aside, so I won't be using this. And I'll bring out the one I made here with the Raspberry Pi. Guess it's kind of hard to see those the numbers with all of the wires there, but anyway, you get the idea. I guess what I have to do first is I got to turn the Pi off and then reboot it because I had it turned off. So let me reboot the Pi. And while the Pi is booting up, I think also towards the end of this lesson I'll talk a little bit about the some features of the C99 standard. But we'll get into that once I give this demo here. RASPBERRY, connect up to the Pi, and now the first thing we do is, let me see, this is lesson 27, MKDIR lessons, and lesson 27. I'll start up Genie. Get her going. Okay, so we left off with this chess program, which again I mentioned now is on my GitHub account, so you can download it and try it. But what I did now is I made another example program. Let me open it up. I won't bother typing it in because they're getting to be too long now, these programs. I put it in my temporary directory called stuff, and I just called it 7segment.c. So the first thing you'll notice is I did 7 defines. So we'll go over the code nice and slowly. Of course I did the include wiring pi.h, because I am going to be using the wiring pi library, and then I defined 7 GPIO pins. So a segment, a LED GPIO is 17. Remember, I'm using here the Raspberry Pi Model A. So on your Raspberry Pi, they might be different. The pin numbers could be a little bit different. Segment B is GPIO 23, C is 24, D is 18, E is 4, F is 21, G is 22. And I have one function I wrote called digit, which is at the bottom of the code. And digit basically turns on a digit 0 to 9 on the LED. I'll show you how that works. So the main program here, we go wiring pi setup. And the first thing I do is I initialize all 7 GPIO pins to output, because basically I'm sending a 3-volt signal to each one of these guys. And you notice in my diagram here, I have 1, 2, 3, 4, 5, 6, 7. I have 7 1K resistors in series with each LED, just to limit the current so it won't draw too much current from the Raspberry Pi, so the segments won't come out too bright. So okay, going down here, so now in my main program, all I have is one for loop. And what I do is I go counter here, I go 0 to 9. So from 0 to less than 10, which is 9. So I'm going to be displaying each of the digits, first 0, then 1, then 2, then 3, then 4, then 5, then 6, then 7, then 8, then 9. And in between each digit, I'm going to basically pause for 1 second, delay for 1000 milliseconds. So that's my complete main. Doesn't really do anything more than that. But now if you look at this digit function that I wrote, all it is one switch statement, depending on the value of n here. Because see, I, remember, is copied to n. So just to review this, I is the actual parameter and n is the formal parameter. So I starts off to be 0. So the first time I call the function, n is 0. So with n is 0, I basically turn on all the segments except segment G. Segment G is the middle segment. If I bring up that diagram again, you can see here that segment G is the middle. So what I'm doing is, let me put this maybe down here. So you can see I'm turning on all of the segments to high except segment G. Segment G remains low. So that means this G is off. So that's how I get a 0, is by turning on 6 segments, A, B, C, D, E, and F. Turn them all on. And then when I call in this for loop, when I call the digit the second time with I is equal to 1, then I hit case 1, and with a 1, I just want to turn on B and C. All the other segments have to be off. So see, B and C give me a 1. And that's all this is just the code all the way down to case 9 to draw the number 9 or the digit 9. And that's the whole program. Nothing fancy. So when I go to here, well, first of all, let me save that in file. I'll save that as, instead of in stuff, I'll put it in my lessons, and this will go into lesson 27. 7 segment save. Okay, so I'll change directory to lesson 27, and there I have it. So now I can say GCC minus O7. So I want my executable to be called 7 segment, and then minus L wiring capital Pi. I want to include the wiring Pi library. So it compiles okay, and you can see I have it here. Okay, and so now I'm ready to just run it. So I can say sudo /7, and it should go 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9. And you notice when it gets to 9, 9 just stays on. Okay, let's try that again. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay. Now if you wanted to turn everything off at the very end, then you could have just before the return in here, we could just put in a bunch of these digital writes to low. Which one do I have? To a lot of lows here. Oh, this one seems to have a lot of lows. So I'll just cut this out here, and then I'll bring it up here, and I will just put it. Oops. Got to do that again, because I should have copied first. Copy. Go back up here and say paste, and just so I want to turn these guys all back off when I'm done. I just want to change them all to low. Okay, so if I go save, and I can compile again and run it again, and this time 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, and then they all go off. In fact, you can verify just by using the GPIO read all. Remember that command, GPIO read all, which shows me all my pins. And if you look at, for example, GPIO 17, which is right here, it's a 0, or it's a 0 right here, 0 volts. That's 17. It's set to output, and it's 0 volts. And if you look at 23, where is 23? 23 is over here. It's also set to output, and it's 0 volts. Okay. If I wanted to, I could just turn one of these guys on all by itself. Remember how to do that from a previous lesson. GPIO minus G, because I'm using GPIO numbers. And I want to say WRI write, and I want to write to GPIO, let's say I want to write to GPIO 17. 17, I want to write a 1. Hopefully one of those segments will come on. Well, 17 is segment A, which is the top segment, and you can see it came on. Over here you can see it's on here. And if I did the read all, you'd now see that 17 is now, there's a 1 there right here saying its voltage is a 1, or a true. Okay, so that's all we're going to do with the GPIO pins today, but I wanted to just introduce you to some of the features of C standard 1999. So far what we've been using, when we just say, when we compile like this, without any options to the GCC compiler, we're just using the 1998 standard. So what I'd like to do is, from now on, from starting on lesson 28, which is our next lesson, I would like to start using C99, or the 1999 standard of C. So there's a few things that are nice about the 1999 standard, and I'll just demonstrate them for you. Let me make a new program here. Well, first of all, I don't need this anymore, so let me just turn that off. I'll make a new program here. Number sign inclu bracket stdio dot h, and then I'll say int main, and let's just try this for loop, int I, and then I'll say for I equals 0, I is less than 10, I plus plus, and I'll do a little for loop here, printf, the value of I is %d slash n, quote, comma I, and return 0. And that's the end of my program. So let me just, I'll save this guy. I'll save it as, I'll just call it, well, in lesson 27, and I'll just call it C99 test.c. Okay. Well, so this will work with C98. So if you look at my project or my build here, set build commands, you'll notice I'm just using GCC with no options, okay, but I am including the wiring pi library. So by default I'm using 1998 standard of C. Okay, so if I compile this guy, build success, and I will execute. Oops. Oh, I'm still running this guy in using the old font. So let me change this back. I'll change this back to, I want to just set it back to, let's say free mono, and let's go back to maybe 18 point. Say OK, OK, and you can see how this ran. The value of I is 0 all the way up to the value of I is 1. Okay, cool, that works. Well, now what I'm going to do is I'm going to introduce a C99 feature. I'm going to take the I out of here like this, and I'm going to put an int in here. Int I equals 0. So I'm putting the int right inside the for loop. So let's save this guy, and I will do a build on it. And you see I got an error. It says the for loop initial declarations are only allowed in C99 or C11. Okay, so since I'm running in C98 mode, I get an error. So what I'll do is I'll change my build here, my build commands, and instead of using GCC, I'm going to use C99. C99. So the C99 is basically just an alias for C98 with an option to use the C99 standard. Okay, so we'll set that from now on. We'll just say C99. So now if I go and say build, it ends up with a successful build, and then I can say execute it, and it executes correctly. Okay. So you're probably wondering, well, what's the point here? Well, the thing is that with C99, they allow you to put the declaration of the control variable right inside the for loop. which means it's local only for the for loop. In other words, if I was to print the value of I is outside the loop, then that should not work. Let me save it, build, and you see now it says there is no I outside the loop. I is confined to the loop. Okay, so and you notice here I don't have any braces for that printf statement, because if you only have one statement in the for loop, you don't need braces. It's probably a good idea to put them in though, so I'll put them in here like this, just to emphasize like that printf here is inside the for loop, but this printf is outside. This printf is outside the loop, and outside the loop this I does not exist, and that's why I get this error. So just to show you, I'll get the error again when I build it. You see I get the error. There's no such value for I. Okay. So this is one of the features of the C99 standard, is that you can declare the control variable of a for loop right inside the loop itself, and that control variable exists only during the lifetime of the loop. In other words, once you get out of the loop, this I no longer exists, so you can't use it down here. There just isn't an I here. But there is if you make it up here, like this, int I equals 12, and then I put the print statement of I is %d/n quote comma I. In fact, what I'll do is I'll even add in here I is equal to I plus 1, like that. Okay, so it looks like I just have one I, but in actual fact I don't. I have two I's. I have one I inside my for loop, like this, and the other I is outside the for loop. It's this I here. So let's do the build. Remember, we're building with C99, so it worked. And if I execute it, I end up with, see the last line, the value of I is 13, because this I was initialized to 12, and I incremented that I to 13, and I printed it out as 13. But this I inside the loop, pardon me, this I inside the loop went through 10 times, and then once I finish the loop, this internal I is gone. Does not exist outside the loop. Okay? Well, another thing you can do with C99 is you don't even have to declare everything at the top of the program. You can actually declare stuff anywhere. I equals, say, 33. You can declare it anywhere. So, but you got to be careful where you declare it, because where you declare it is important. So in this case here, I'm declaring it down here after the for loop, and so this I will be 34. So let me build it and let me run it. Let me close that window here and execute it, and you can see I is 34. See, the rule was for C98 was that all declarations must come right after an open brace. So in C90 or in C89, I would have had to done this: int j equals 34 or 33, and then I would have had to say int I, and then I would have to take this out here like that, and change this guy here to a j, and change all of this over to a j like that. See, so remember in C standard 89, all your declarations have to come they have to come right after an open brace, because they have to be inside of a block. And if you look at the block here, this brace and this brace, so these variables j and I are active and alive inside this block. Let me change this a bit here and show you another interesting thing. If I say int, for example, I equals 21, and then I have another brace like this, and I say int I equals 33, and then I say printf value of I is %d/n quote comma I, and then I'll close this block off, and then I'll say another print statement, and I'll say this: the value of I is that. Let me just increment them to do some work here. I plus plus like that, and in fact what I'll do here is inside here I'll say I minus minus. So let me save this guy. I'll save it as, I saved the other C99 test. I'll call this test 1. So what would you expect to happen here? Well, you see this block here contains this I here, which is 21. I increment it here to 22, and it prints out 22. But this I here is inside this block here, so it exists only inside this block, and it's initialized to 33. I subtract 1, becomes 32, so it prints out 32. Well, let's try it. Okay, and if I run it, well, you can see the first one is 32 because it was initialized to 33, and I subtracted 1 from it, so it printed out 32. The next one is initialized to 21. I add 1 to it, and it prints out as 22. Well, this code here would work correctly in C standard 89, but it also works in C standard 99. But in C standard 99, I could have taken this declaration here and I could have moved it down here. Like, for example, I could have said int I equals 21. I could have moved it down here, and I believe this should still work. Let's give it a try. Build, and it finished successfully, and if we run it here. Okay, and you see we get the same results, 32 and 22. So, well, these concepts here are a lot to grasp in a few minutes. but let me just go over the two ideas. I'll put them down in our notes here. Maybe I'll just add that on to here. I'll say C99 features. And so one of the features is we can declare loop control inside for loop. We can declare control variables inside the for loop, which means that they only exist while that for loop is running. Once the for loop is over, those variables that were declared inside that loop are gone. Okay. The other feature is that we can declare variables anywhere. Well, let's see. Almost anywhere in the C program. See, before in C89 we had to declare immediately after an open brace. So in C89 we had to declare immediately after an open brace. So if let me just save this guy here. If I go to here, you see how this guy is not declared after an open brace. See? So he should have been, in C89, he should have been declared right after this open brace. But in C99 we can put it wherever we want. I don't know if that's such a big advantage. Sometimes some people say it just makes the code more confusing. But so, for example, if I was to switch my compiler back, see this guy here, if I go build and I say build, it compiles successfully. But if I change it back to just GCC, then it should not compile. See, I got a warning message on line 12. Well, main warning, control reaches end of non-void function. So somehow this guy got all confused. I'm not quite sure, but I know that if I change this back here, if I change this back up to here, and I just eliminate that for a second, if I now build it with C98, oop, what happened here? Am I still 1, 2? Oh, no, that's right. I wonder why this is not compiling. Let me strip this out here. Boom, 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 boom. Actually, it's just a warning message. I mean, it did work. It did work here. Try it again, build, and I get that warning message, but it did finish successfully, so it would run. But if I take with C98, if I put this guy, do I get the same error message? And now I go and build it. I get the same error message. It's just a warning again. But in any case, the best thing to do, and I'm going to do this from now on, is I'm going to change this to C99 to compile with the C99 standard. So build, and now it's successful, and I can run it, execute, and it works okay. Okay, well, that's a lot to take in, but you have an opportunity now to play with 7-segment LEDs, and you can play with more with local variables belonging to blocks, and also to do I have any more here? Also with variables declared inside for loops. Okay, I think this lesson has been going on for too long, so I'm going to cut it now, and I will see you later for lesson number 2.